All right, well, here we are. We're going to look at today's section P6. So, this is a section that's just sitting right in front of chapter 1. We're not going to spend a significant amount of time on this section. In fact, what you'll probably find a lot of these videos, some may be longer, some may be shorter. They might not necessarily match up identically with what an entire class session would be. And part of that reason why is because there's just not the student interaction that you'll see in a normal classroom. So that's one of the sad things about doing this whole online format. However, I really think that having the accessibility and ability to for you to go back and check out these videos at your discretion, you can look at them, you can review the content, you can see examples as I go through them at your discretion. So I think that's a huge plus here. And so we're going to go ahead and jump into section P6, and I've got the notes all typed up here so you can take a look at them. Section P6, really what we're going to do is we're going to look here at these questions, or at these notes, and then we'll jump into a few examples, okay? So this should be just a review, basic review for many of you. We're looking here at complex numbers, okay? So the number I right here, we represent that as the square root of -1. Now normally you can't take the square root of a negative number, and so mathematicians in their cleverness have come up with a way to write it, and that is just the letter I. The important thing to note is that I squared is equal to -1, okay? And the reason why is if you think about the square root of -1, if you square this thing, it actually will wipe the square root out. So that's why that works. In fact, that application we'll actually see a little bit further down here in the notes as we go and talk about higher powers of I. You'll see that as it plays out. So an imaginary number, if you have a positive real number, so square root of -a, that equals I times the square root of a. In other words, you take any number and you'll have I pulled out in front of it. Okay, so here's an example I have, square root of -27. This is the same thing as I times the square root of 27, right? And then what we do is, since you can take the square root of 27, it's going to be 9 times 3. So think about what's underneath the square root. You technically can't take the square root of 27. I misspoke right there. What you can do is you can break this into a product, one of which of those items has a square root. That's why that 3 comes out in front. So if you think of 27 as 9 times 3, or another way of writing this is the square root of 27 is the same thing as the square root of 9 times the square root of 3. Okay, so you've got I times the square root of 9 times the square root of 3. Square root of 9 is 3. So that 3, we can actually pull that right out in front and multiply it by that I, and the one thing that's remaining that we can't take the square root of is 3. Okay, so this here is the final and simplified version of square root of -27. Okay. One of the things you'll notice too as I go through a lot of these videos, I'll verbally say things out loud to communicate it without writing it down. And part of the reason why I do that specifically is for you to start engaging your mind to think through, okay, like how does that work? The square root of 27, I can split the 27 into 2 pieces, the 9 and the 3. The 9 has a square root, so you can begin this process of just working in your mind some of the mental math. Okay. Now a complex number, you might be surprised, an imaginary number and a complex number are actually 2 different things. A complex number is a number that is comprised of or made up of both a real part and imaginary part. So you've got A, which is your real part, and BI, which is your imaginary part. So really what we have is A plus BI, and there it is. They together, when you add them together or subtract them or have some kind of combination of them, they form a complex number. Okay. Standard form is just going to be a plus bi. Pretty much that's how every complex number is written. One thing to note, if there's a 0 in either of these parts, that really, it's still going to be in standard form. So for example, if a is 0 and I just have bi, or let's say 10i, that's still going to be a complex number in standard form. The a is just going to be 0. The same thing applies with bi. If that is a 0, if the b is a 0 here, and the a is some number, say, I don't know, 6, that technically is in complex form or in standard form. It is a complex number in standard form. The only problem is that you're missing the imaginary part. So it's a weird mathematical distinction, but I just wanted to point that out. So how do we deal with complex numbers when we add them together, when we subtract them, when we multiply and divide? That's a great question. So we'll go through some examples here, but I do want to just show you a very basic example. Really, all we do when we add and subtract is we just combine the real parts and the imaginary parts. So in other words, if I've got this, okay, don't look at this stuff yet. If I've got this, what I'm going to do is I'm just going to merge the 3 and the minus 2 right here. Okay, that minus sign needs to distribute through to both the positive 2 and the negative 2i right there. So I've got 3 minus 2, okay? So that's ultimately going to produce a 1. The minus distributes to that minus sign and both the, so it distributes to both of these numbers. So this becomes a negative 2, that becomes a positive 2i. So now I've got the 4i, the minus 4i here, and the positive 2i there. So I literally just merge those together. So again, you're only combining just the pieces that are the same. So the real parts, you're just going to combine those. The imaginary parts, you are just going to combine those as well. So it's pretty straightforward with the adding and subtracting. The powers of I. So the reason why I put this in here before multiplication and division is because multiplication and division utilizes a property of powers of I. So these are pretty important to know, actually. So really, and I'm going to show you a cool little way to remember it here when we jump to our whiteboard. I to the first is going to be square root of negative 1. We define that right off the bat. That was way up here, actually. We have I squared is equal to negative 1. Square root of negative 1 times square root of negative 1 is just going to be negative 1. I to the third, or I cubed. You can think of it as I squared times I. So we'll just take these pieces and multiply them out. We've got minus 1 times I, which is the same as minus I. And then I to the fourth is just two I squareds multiplied together. So we just get a positive 1. So these are actually pretty important to know. And the reason why is because as soon as you start going and increasing higher powers, which we'll talk about a little bit further down, they actually rotate. So when we go up to I to the fifth, we'll actually start right back here at I to the first with square root of negative 1. I to the sixth is going to be the same as I squared, which is negative 1. I to the seventh is going to be the same as I to the third, which is negative I. I to the eighth is going to be the same as I to the fourth, which is positive 1. And then it just keeps going around and around and around. That's essentially how higher powers of I work. We'll get into that just down here. I'll explain kind of a real simple process for how you can figure that out. Multiplication and division, you can pretty much ignore what this is. This is kind of like the real mathematical way of doing it. We're going to go back to our FOIL pretty much. So first, outside, inside, last. And that's really all this is. What I'm doing is the first times the outside times the inside times the last. Then I'm combining by adding and subtracting the parts that are the same. And then what you find is that you get something that looks like this. You probably don't want to memorize this. It's kind of a weird thing. literally just multiplying it out is a lot easier. And again, I'll go through some examples. Complex conjugates. So when you're dividing through powers of I, sometimes it's helpful to get rid of a power, or I should say one of these, something in this form. And the way to do that is to multiply by the complex conjugate. And the reason why is, if you remember, going back to intermediate and elementary algebra, that when you multiply by a number, so say you have two things here that are exactly the same, but the sign in between is different. So this is a binomial factor. When you multiply two opposing binomial factors where the sign is different, what happens is it wipes the middle term out. So essentially what you would get is, if you multiply this times this, you would get a squared minus b squared times I squared. And the I squared, remember, is -1. So it's kind of a clever trick, actually, to get rid of something like that when you have it in a fraction. Again, we'll do an example of that, so hopefully you'll understand what I'm talking about. Higher powers of I, the trick here is you divide by whatever the power of I is that you have by 4. So for example, if that is actually a formatting error, I'll have to sort that out, but this should be I to the 253rd power. Okay, I made a mistake when I typed this up. I to the 253rd power, or to the 1253rd power, I should say. So 1253, what you do is you divide it by 4, and you get 30.25. Really what you're looking at is the fraction, okay, or the decimal point. The 0.25, remember, it's cyclic. It keeps going around in a circle. So you look at the remainder, or whatever the fraction is, and whatever the remainder or fraction or decimal point corresponds to in your 4 powers of I. So this right here corresponds with 0.00. This is going to correspond with 0.25. This is going to correspond with 0.50. This is going to be 0.75. And then it returns back to the top again, 0.00, 0.25, 0.50, 0.75. Or you can think of it as 1/4, 1/2, 3/4, 1. Right? Same thing. The 0.25 corresponds with the first power of I, so I to the first. If there was no decimal, we get an integer when we divide. We have I to the 0, which is equal to 1. So think about it like this. I to the 0 is 1, and I to the 4th is 1. So those are the same things. Okay, so again, you get this cycle. In fact, let me show you a cool little trick that I use to remember it here real quick. So let me go to the board. Okay, the little trick that I use is I'll think of, we'll go through some examples here, but I just want to show you this cool little trick to help remember. Okay. So here we have our x-axis, here we have our y-axis, okay? Or you can think of this as A and IB, it's fine, it doesn't matter. And so what we're going to do is you think about a distance of 1 on each of those axes, okay? So this is 1, this is going to be, so it's on the I-axis, so this is I, this is going to be -I, and this will be -1. Okay? So what happens is when you're looking at, say, I to the first, this is equal to just I. Okay? So it's going to be right here. So this is I to the first. I squared is equal to -1, which is back here. Okay? -1. Or I should say I squared. Okay, I to the third, this is equal to a -I to the third, and I'm guessing you see the pattern here at this point. This is going to be 1, right? I to the fourth, okay? So what happens is you start with, I guess if you wanted to start at I to the 0, you could do that too. This is going to be 1, so this is the same as I to the 0. What you do is you keep going around in a counterclockwise pattern to kind of follow where you're at. So this is when you're increasing powers of I. When you go backwards, it actually flips and goes backwards as well. So what you have is, say you've got I to the negative 1, okay? I to the negative 1. Technically, if we're using the rules of fractions, this is going to be 1 over I. Okay? Sorry, I know I'm right on that hot spot, which is right where the lamp is. Unfortunately, I'm trying to sort out a way to actually cover that up. I might get like a sheet or something to cover it up so it's a little bit more diffuse. But this is what we got right now. So this is 1 over I. Okay? And so what happens is when you actually have a negative exponent, you actually go in the opposite direction, okay? So this would be the same as negative I. And the same applies when you go back I to the negative 2. This is the same as 1 over I squared, which is equal to negative 1, okay? And so on and so forth, right? So you can go forwards and backwards, and it makes no difference whatsoever. So that's, again, just a little trick right there just to help get you moving along if you're trying to figure out powers of I. All right, let me get my eraser, which is a napkin. Here we go. All right. So let's go ahead and continue. Let's go through some examples now, similar to questions that will be on your homework assignment. Okay, this again is going to be a lot of the structure of this class, a lot of the sections that we go through here in the textbook. I'll go through problems that will be very similar to questions that will show up on your homework assignment, so bear that in mind. All right, so we are going to look at question number 10 out of the textbook. So this is question 10. It's asking us to find the square root of negative 64. Okay, so this is the same as I times the square root of 64, right? Because remember, based on the notes, if I go back to it, you can see right at the top there, under the imaginary number, I'm going to pull that I right out. Okay, so we're going to do that right there. So this becomes I times the square root of 64, which is equal to 8. And normally the way that we write this is we put the number in front of the imaginary unit. So this is going to be 8I. Okay? So that's question 10. Question 14. Okay? You'll notice I'm probably going to go through a lot of these questions relatively quick, so bear that in mind. But you know, you have access to go back and watch it. In fact, on YouTube, you can even go as low as quarter speed, I believe. So if I'm talking too fast, just slow it down. It's amazing. Technology is pretty awesome these days. All right, minus 9. So this is actually one of those things where let's just simplify it as quickly as we can. So this is square root of 25 is just going to be 5. Square root of minus 9, this is going to be I times the square root of 3. So we got the plus sign in the middle. I times the square root of 9, which is equal to 3. So this is equal to 5 plus 3i if we wanted to write it in standard form. Okay? All right, 18. 11 plus the square root of minus 48. Okay? So this is the same as 11. That's already done, which is great. The minus 48, this is going to be the interesting one. The suggestion I give to you is to try to break it down into prime factors. So, for example, let's just go here. 48. Let's see. So it could be... trying to think. Probably we could do 16 and 3, I think. Yeah, 16 and 3. Trying to think. 8 and 6, right? 4 and 12. Okay. 2 and 24. Okay. Now, here's the deal. You could use this one, and the reason why is because 4 is a prime number. But I'm actually going to use this one because I want to choose the higher prime number. That way I won't have to do another prime factorization of 12. Because if I get the highest, it's not really a prime factorization. I should clarify that. It's just a factorization that when you look at it, you want to find the highest square root. Okay, so the highest square root of is really 16. The highest number that has a square root is 16. So that's what we're going to do. So this is going to be plus square root of 16. So this is I in front times the square root of 3. Okay, so now we've got 11 plus square root of 16 is 4. So this will be 4i times the square root of 3. Okay, so that's that number. That question. All right, let's do a few more. I'm going to do a adding one real quick, and then we'll do a multiplication one. All right, so let's do something that's like a bit of a combo. 33. This is going to be 3 times 2 plus 5i. Minus 2 times 3 minus 2i. Okay. So again, let's first off multiply and distribute those numbers through each piece. Okay, so 3 times 2 is 6. 3 times 5 is going to be 15. Excuse me, times I. Minus 2 times 3 is going to be a minus 6. Minus 2 times a minus 2i. Is a positive 4i. This is usually where a lot of people get flipped up or screwed up. What they'll do is they'll actually go ahead and take this number and they'll forget that there's a minus sign in front of it, and so they'll just say, oh, the minus 2 times is going to be minus 4. So that's something to be aware of. Make sure that you're distributing that minus sign as well. Okay. All right, so now what we've got is 6 minus 6, which is 0, and then 15i plus 4i is going to be plus 19i, and so this is literally just equal to 19i. So that's question 33. All right, so again, remember here, sorry, I jumped through that fast. We're combining only the things that are alike. So the things that have one underline is what I'm combining. The things that have 2 underlines is what I'm combining as well. Okay, only combining like terms here. All right, 36. 6 plus 5i times 2 minus 5i. All right, so let's go ahead and FOIL this. So we'll FOIL. So we'll do the first. 6 times 2 is going to be 12. The outside, 6 times minus 5 is going to be a minus 30i. The inside, 5 times 2 is going to be plus 10i. That's a 10, by the way. Sorry. Plus 5i minus 5i is going to be a minus 25i squared. All right. So let's go ahead and combine everything. 12 minus 30 plus 10 is going to be a minus 20i. Then we're going to have a minus 25i squared. This is the thing that is important, okay? This right here. Because I have an I squared, remember, what does I squared equal? I squared is equal to a minus 1, okay? So we can actually go ahead and make that substitution. This is the same thing as minus 25 times a minus 1. So now what we have is 12 minus 20i. Minus 25 minus 1 is going to be a plus 25. And then we combine the real terms. So the 12 and the 25, which is going to be 37 minus 20i. And that be it. All right, so remember, when we're writing things in standard form, we must, every single time, no matter what, we must always get rid of the higher powers of I. Standard form is only going to be a real part and a single imaginary part. You cannot have multiple powers of I showing up in your final answer. Okay? Every single time you must reduce those higher powers of I. All right, let me do a different one. Let me show you how that complex, or that, the complex conjugate, where it shows up. Okay. Multiplying by a conjugate is something that's actually really handy in a lot of other areas of math, especially in trigonometry, if anyone ever plans to do that, or if anyone is going to move into calculus, that shows up pretty often, in fact. Not necessarily in complex numbers, but just in manipulating equations to get to positions or places that make it easier to work out. Okay, so this is the question, and we're asked to simplify this into its standard form. This is not in standard form. So you can actually, because you have an a plus bi in the denominator, that is technically not standard form. Standard form is a plus bi, period. Not in the denominator. It's just a plus bi. So there's a way to do this to make it easier to get rid of it, and that is where the complex conjugate comes in. So what we're going to do is this little sleight of hand. It's a little trick here. So you look at the denominator and you look at the complex number, and then you're going to multiply it by the exact same thing, but you're just going to flip that middle sign. So this is going to be a 3 minus 4i. Okay? And I do the same thing on the top. Now, think about it like this. A lot of people have problems with fractions, and so I hope this explains it as best as I possibly can. Think about 3 minus 4i divided by 3 minus 4i. That's literally just 1. Okay? That is literally just 1. So I'm just taking my initial problem here, and I'm just multiplying it by 1, which anybody can do. My camera's going to turn off. It does this periodically. I'm just going to tell you right now. So I just heard it. The shutter open and close on it. And it will take me just a second to get that going. I think it's like there's a timer on it, and I'm not sure exactly why it shuts off, but if you see it shut off periodically, just be patient. It will come back, I promise. All right, so here's what we're going to do, okay? We're going to multiply by the complex conjugate. So we'll do the numerator and denominator separately. So 5 times 3 is going to be 15. 5 times a minus 4 is a minus 20i, okay? Divided by, now we multiply this guy right here. 3 times a 3 is going to be a 9, okay? Watch what happens. This is going to be awesome. Okay. So let's just pretend to FOIL this thing. I'm going to show you what happens, but you should know this already. Let's just work it out though for the point of the argument. 3 times 3. First outside, 3 times minus 4 is minus 12i. Inside, minus 4i times 3 is going to be, plus 4i this is going to be a plus 12i. Then I've got plus 4i minus 4i is a minus 16i squared. Okay, so this is all in the denominator. Take a look at what happens. These cancel. Okay, so those are gone. So we're left with 15 minus 20i divided by 9 minus 16i squared. Okay, now the 16i squared, the thing about that that's really cool is, remember, we know I squared is just equal to minus 1. So literally this is the same thing as 15 minus 20i divided by 9 minus 16 times minus 1. Okay? And again, we can break this down even further. It's 20i all over 9 plus 16. Just so you know, I'm writing a lot of this stuff out right now. As we start to get a little further into the semester or the course, I'm pretty much just going to be assuming that these earlier things, or the kind of working it out, showing every single step, that you're capable of doing it on your own. And so my suggestion to you is that as we go through the semester or the course, and you start to, maybe you have a question like, hey, how did you jump from this step to that step? Maybe just take some time, pause the video, go back, and just work it out. I always encourage everybody, hey, like, normally in a face-to-face class setting, I have a tendency sometimes of making mistakes on the board. I'm not immune from doing that here in my office working on this whiteboard. It happens. Some mistakes happen. So if you get stuck on something and you're like, I have no idea how you got to that, and you work it through, it is possible that I literally just made a mistake. That happens. But not only just the fact that you should be checking me to see if I make mistakes, as rare as they are, they do happen. It's not very common, but it will happen. My suggestion is to just work it out, because it really is just building certain pathways in your brain to be able to do it. In fact, again, this is kind of a philosophical thing. So you're not in philosophy, you're in math. Oh my gosh! But I do want to illustrate something for you that actually in neurology, the way that people have studied the brain, that the more that you do something, the more that you partake of a certain activity, the more it builds favorable neural pathways in your brain so that you don't even have to think about doing them over time. A lot of this stuff that we're doing here, when I was an undergraduate, studying for my math degree, I just did it over and over and over and over again. And so now it's gotten to the point where I really don't have to think too much about it. It's just become a reflex. I know how to do it right off the bat. And so, again, I know that this course is just a college algebra course, but that's something actually that's not just a college algebra tactic. It's something that's actually true for pretty much anything you do in life. So this is Rob giving you your 5-minute life skill lesson right there. Okay, back to the math. So here we go. 15 minus 20i, 9 plus 16. This is going to be 25. So we've got 15 minus 20i all over 25. Okay, we can actually reduce this down here. I'm going to bring this over here so you see it. We can do 15 over 25 minus 20i over 25. This is the same thing as 5 goes into these things 3 times. 5 goes into 15 3 times. 5 goes into 25 5 times. 5 goes into 24 times. And 25 5 times. Okay, so this technically is the final answer. Again, I'm sitting right on that light, so if you can't read it, it's 3/5 minus 4i over 5. Okay. All right, so let's go ahead and do one more question. One more question. I want to show you also a little trick that you can use when you're working on your own. In fact, I encourage everybody to use technology as much as they can. You need to know how to do it, but at the same time, why forsake technology when it's accessible to you, right? We do live in the 21st century, so let's just use it if we can. We're going to do I to the 66th, okay? So I to the 66th. So what we're going to do here is, again, this is a higher power of I, so we take 66 and we divide it by 4. Okay? And if you punch this into a calculator or you check it online, what you'll find is that the answer is going to be 16.5. Okay? So remember the 0.5. Remember our powers of I. We've got I to the first is equal to I to the second is equal to -1. I to the third, negative I to the fourth is equal to +1, right? So that's, again, it's cyclic. So this corresponds right here to 0.00. This is going to correspond to 0.25. This is going to, these again are just remainders, okay? That's important to remember. 0.50, and then this is going to correspond to 0.75. All right. So now the 0.50 right there, this is going to be I to the third. So I to the 66th is equal to I to the third, which is equal to negative I. Okay, so that's our final answer. All right. You know what? I think I flipped. Yeah, sorry. See, this is one of those mistakes. I just told you it was going to happen. I changed it. This is actually 0.25. This is 0.5. This is 0.7. I was looking at this and I'm like, I don't think that's right. Yeah, so this is actually not I to the third. This is actually going to be I squared. Hey there. Day one. Boom. All right, now we're good. I squared minus 1. Boom, there it is. So that's our final answer. Now I want to show you something real quick. Let me go to my browser. Just give me 1 second because I need to pull it up and show you where to go. I just lost my marker. All right. Man, my browser's taking forever. Here we go. Switch to this guy. All right. Hopefully you all can see my browser here. Let's go to wolframalpha.com. And if you can't see it, I'm going to zoom in on it. Okay, there we go. wolframalpha.com. You can do a lot of these problems here in Wolfram Alpha. Okay, so for example, I was going to do a more complicated problem with doing the complex conjugate. There's really no point to it. I'm going to show you how to do it here in Wolfram Alpha. This is actually question 54. And question 54 says to do minus 4 minus 39i divided by 5 minus 2i. Okay. So I got to do my brackets correctly. And I need to, so this is the numerator and the denominator. I'm separating them using brackets. And if I literally just punch that in, it should bring up the standard form of it. If I'm, see, there it is, 2 minus 7i. How about that? If you want me to prove that that actually is the correct answer, then what you can do is multiply this whole thing. So I'm going to do another bracket here. You multiply it by the complex conjugate, which in this case is going to be 5 plus 2i over 5 plus 2i. Okay. And if I multiply that out, see what happens, I get the exact same thing. Okay? So that's pretty cool. You can do higher powers of I. You can do pretty much everything here in Wolfram Alpha. So let's take a look specifically at question 64. Okay, for example, this one says 1 over I to the 83rd power. Okay. So that's the input. The result is it gives me I, which is I to the first. Okay. This is the same thing, by the way, as I to the negative 83rd. Because it was in the denominator, I can make it positive by flipping the sign in the denominator. So again, that's the same thing. And again, my result is going to be exactly the same. Okay. Now another way to do it too is, again, you can take, well, the negative is a little different, but yeah, I won't get into that. You're fine. You should be all right. All right, so that's pretty much it. I mean, yeah, if anybody has any questions, shoot me an email. Let me know. I'm in OBS here. You see here. What is going on? All right. Switch there. So yeah, we'll go ahead and call it for this class session. And if anybody, like I said, if anybody has any questions, feel free to let me know. You can shoot me an email through Canvas or just respond to this video on YouTube as well. All right, have a great one.